Welcome back, folks. In today's class, I'll be talking about finding the confidence interval for the population mean. Confidence, confidence interval for population mean. Now, in the last class, if you can recall what we talked about, I took an example. Let's say if I have 1,000 data points and I take the mean value from that, the average height example. So average height of a Canadian man, I took a data sample of 1,000 data points for that, and average came out to be 175 centimeters. And then I was able, by using that sample size, I was able to make a prediction by using the Z value and the probability values. I was able to make a prediction that what percentage of data point will be above 180 centimeter, which in turn I can say what percent of people whose height is above 180 centimeter, or what percent of people whose height is below 160 centimeters. So all sorts of those predictions we were able to make. And now in today's class, I will be talking about the confidence interval for the population mean. So this was the sample of 1,000 which I took, or I can say that this was more of a population which I considered as. So I was able to make a prediction about this particular population, assuming this is the whole population. That's what I was able to make a prediction. But in reality, this 1,000 is not a population. This is just a sample. So how we can make a prediction about the population means, because no one knows actually what is the average height of a Canadian man in real life. If no one has collected that much data, that he can collect all the Canadian men and go and ask them and then put the data in an order and calculate what is the average height. So how does they make the prediction? If you're going to go and Google it, you will be able to find out what is the average height of a Canadian man. How they make the prediction? They make the prediction with the help of CLT theorem. So central limit theorem, CLT. Now what happens in that one is the people gonna collect small data points. The data point, the small datas, like one set of data should have minimum 30 data points. I'll tell you also why minimum 30 data points, because it has been observed when you have at least 30 data points, you find that data starts showing the normal distribution. So it starts behaving normally like this. That's why we will keep this assumption of the 30. So and then I collect another data point of 30 samples, point 30 data points. So you can collect it from the one big sample also. So remember, I talked about there was 1,000 data points we had, and I can take 30 from here, 30, another 30, another 30. I can collect a multiple samples. So what I can also do is, if let's say 15 data points have been used here and 15 have been used here, so I can pull 15 from here and pull 15, another 15 from here, and collect, make another sample size. I can pull up 5 data points here and 25 data points here. I can collect another sample from here. So all these multiple samples which I have collected, small samples, I'm going to calculate the mean of this. So this will have another one mean, this will have another mean, this will have another mean. So once these means, I'm going to put in order. Once I'm going to put all these means in an order, I will find that they will also show the normal distribution. So what does central limit theorem says? Central limit theorem says that the mean of the means, so the mean of the means will be the mean of the population. So if I put them in the order, so if this is, let's say, this sample size, the mean value came out to be 160, here came out to be 165, here 175, another sample, it came out to be 195. So I'm going to start putting them in the order. Sorry, my apologies, guys, my phone rang up. So now I'm going to put them in order. This value is, let's say, 165 centimeter, and this value is 195 centimeter, and another sample which has a mean of 160. Well, this should be 180 centimeter. So all these means which we calculated. Now I'm going to take another mean of these. So these all are means of the small samples size of small samples, shall I say. Yeah. So this sample is of 30 data points, this sample is of 30 data points, this sample is of another 30 data points. Data points has a mean of 165, this has a mean of 195, this has a mean of 180. So if I'm going to take the mean of these means 165 and so forth, 180 and keep going on 195, if I start taking the mean, so that this mean, whatever mean you're going to get from here, let's say it comes out to be 176 centimeter. So this mean will be close to the mean of the population. This mean will be close to the mean of the population. So the mean of the population was, I assumed, again, if I assumed it was 175 centimeter. So you will find for all your samples, if you collect large number of samples, their mean, so the mean of their means will be approximately close to 175. So here I said 100, and it can be 176, it can be 174, it can be 174.56. It will be ever so close to the mean of the actual population. That's what I am trying to say. So now, so that was about the center limit theorem. And now what I wanted to do is I wanted to create a confidence interval for the population mean. So what does that mean? uh, that means is, let's say I collected a sample. My sample is of 30 data points, and then I collected the my sample is of 30 data points, and I collected the mean from here. The mean value of these data points came out to be let's say 170 centimeters. Okay. Now what I wanted to do is I wanted to make a prediction. I want to make a prediction that how many uh, that what what percentage of confidence I have that the mean of the population will lie close to this. Okay, that's what I wanted to make a prediction. Means by using this 170 centimeters, I want to make a prediction about the population mean. Mu value, we don't know what it is, but X bar for my sample came out to be 170. Okay. Now, because I don't know what's the value is, so just by using this sample, I wanted to make a prediction how confident I am that the mean value will lie close to this. So you can be 99% confidence, you can be 90% confident, 80% confident. So different confidence intervals you can create. So rather than saying that, okay, my the average value which I calculated was 170, so it should be it is close to the 170. We don't do that in stat. It is a pure math. So we need to make a tolerance limit. So we gonna make a limit zone. So maybe I'm gonna say the actual mean will lie between 165 to 175 centimeter. The my mean population, the mean which I calculated for my sample is 170. Now, I created a range, and this is called a confidence interval. I'll tell you also how we create this confidence interval later on. So I calculated a lower limit and I calculated a upper limit. And then I was able to make a prediction that I am 90% confident or I'm 95% confident, depending upon whatever number we have. So right now I'm going to say, let's say 90%. I'm 90% confident that the actual mean of the population, actual mean of the population will lie between 165 centimeter and 175 centimeter, and I'm 90% confident in that. Okay, so that's how we create a confidence interval. Now coming back to the confidence interval, how we gonna create a confidence interval. So confidence interval is created with the formula that is E equal to uh, so E equal to Z alpha over 2 times sigma upon square root of n. Now this E is margin of error. Margin of error. It will be onto the left hand side of the mean you calculated and to the right also. So let's say in this case margin of error came out to be 5 centimeters. So I'm going to create a lower limit of 165 and an upper limit of 175. If the margin of error came out to be 10, so I will say 170, I'll go 160, and here I'll go 180. And how we calculate the margin of error? We calculate the margin of error from here. Now, let's do this question. So I'm going to recall the same numbers. The X bar I got was 170 centimeter. 170 centimeter. And then I will say the standard deviation came out to be, I'm just again taking a random number, 4 centimeters. Okay. And then this piece of information, I guess that's more than enough. I would, you know what, I'm going to use the standard deviation for population here. Standard deviation for population. There is a little bit more depth in this one. I won't go to that level because that'll be too much for our syllabus. Here, I'm going to use the assuming the population standard deviation is known to me, because if I don't have the population standard deviation, then we end up using the T alpha over 2, which is multiplied by S over square root of n. We end up using the T distribution where we use the standard deviation of the sample. Here, because I'm using this formula, so I don't want you guys to confuse, I'm going to assuming the population standard deviation is same as the standard deviation of the sample. That's an assumption I'm going to take. All right. And in exam you will be, or you'll always be using the standard deviation of the population. All right, so to calculate these numbers, so this is what's given to me. I wanted to calculate the lower limit and the upper limit. So margin of error, for that I have to calculate E equal to Z alpha over 2 and then sigma divided by square root of n. This is the formula I'm going to use. Now, I wanted to calculate the Z alpha over 2. How to calculate the Z alpha over 2? So, remember I talked about the confidence interval. I wanted to be 90% confident, let's say. So, I will redraw the diagram so that you can clearly understand what's going on here. So, this is the mean of the population, which we don't know, average height of a Canadian man. But for my sample, it came out to be 170 centimeter. And I took a sample size above 30, so I can assume that that also behaves normally. That also behaves normally. Now, I wanted to create a confidence interval of 90%. 90%. So 90% will be the middle 90%, this region. So middle 90%. Let's say this is the middle 90%. Okay. So how much region is left over here? 5% here, another 5% on this side. So this is another 5%. So I'm gonna find the, sorry, sorry guys. So I'm going to find, first of all, this is the probability value. Probability value is 0.05. Correspond to 0.05. How did I get 5 divided by 100, which is 0.05? Correspond to this probability value, I'm going to try and find out the Z-score. So I'm going to open up the distribution table on my end. You can also check it on your end. So 0.05. It's going to take me a while or a second. So 0.05 is 1.654. So negative 1.6, negative 1.6 5 I'm gonna use the, yeah, so there is 6, 4, between 4 and 5. So you can, okay, so here one more thing I want to tell you. You will find the value, one value is 0.0495, another value is 0.0505. The value is right in the middle of them because we got 0.05. So you can take either any value. You can take 1.64, 1.64. I used 1.65. Whichever is more closer, in this it is right in the middle. When it is right in the middle, you can use any value, 1.64 or 1.65. I will mark it correct. Okay, you don't need to confuse yourself. But if it was, let's say, 0.497, so 0.497 is closer to which? It is closer to this value, so I'll use this value. If it was 0.05, 0.0501, then it is closer to this value. So I'm going to use in that scenario this value. So whatever it is closer to, that's the value I'm going to use. So here I got the z value as 1.65. I'm taking, so z value, see here, why this is alpha over 2. Alpha means, this means the rejected region, this outside region. This is the alpha region. Okay, this outside region. The inside region is the confidence interval region. So that's why I've divided, I'm creating a 90% confidence interval. To create a 90% confidence interval, you have to leave how much? You're leaving the 10%, and that 10% is equally divided over these two regions, 5% here and 5% over there. That's why I took alpha over 2 here. So this came out to be 1.65 negative. So sigma value will be, as it was given to me, that was equal to 4. And the sample, this is sample size, this is square root of 30, and then that's going to be e. So e value I can calculate by, with the help of calculator. So 4 divided by square root of 30, square root of 30, and then multiply by 1.65. That's going to give me 1.204 negative. And if you're going to do this and on this end it will be 95%. So if you're going to say 0.95, see the z value correspond to that, that will also come out to be positive 1.65. And so the error will exactly be the same, because this will just be a positive value. If you're going to go on the positive side, if you're going to go on the negative side, it will be just a negative value. But in the end, error value will be the same. One is positive, another is negative. That's it. So I'll call it as this. So margin of error I calculated 1.205. So I'm going to say 170. So 1.205 minus 1.205 on the left hand side, and on the right hand side plus 1.205. So this value 170, 170 minus 1.205, which is 168.795, and 170 plus 1.205, which is 171.205. So I got these two values. One is lower limit, another is upper limit. So I'm going to say I'm 90% confident. I'm 90% confident that mean of the population will be between 160, the mean of the population here, 168.795 and 171.205. I'm not 100% confident, mark my words. I'm 90% confident. 168.9795. 795. So 90% confident for that. So this way you can, again, you can create a 99% confidence interval also. You can create an 80% confidence interval also. So that's how you create a confidence interval. In the end, how you're going to write it? 168.795 less than equal to mean of the population, less than equal to 171.205. So the mean of the population lie between these two limit. For that, I am 90% confident that it's going to lie between. So if I'm going to collect 100 samples, 90% of the times those samples will lie between these values. So that's how we calculate the answer for the questions. So hopefully you were able to understand how we calculate the actual value. Okay, so that was it from my side. Hopefully you enjoyed this lecture. If you have any questions, you can email me. You can book a timing also, because I know this can be a little complicated, especially the last lecture, the one which I'm doing right now. So if you have any confusion, you can ask me. One before I leave, one more thing I wanted to talk about. You will find some questions on calculating the sample size. Sample size can be calculated n equal to z alpha over 2 times sigma and divided by margin of error square. So sometimes you will be asked, what should be the sample size? What should be the sample size if the other parameters are given to you, if the margin of error is given to you? That kind of a question can be asked to you, and you can calculate it from this formula, or you can calculate it from z alpha over 2 sigma divided by square root. And so it's just the same thing, it's just modified, so by moving the terms around. So these two are same formulas actually. So hopefully you were able to understand this thing. And let me I'll post the questions, which the questions you need to do on the D2L. So now I'm going to stop the video because this video is already getting a little too longer. So I'll see you